effects of relativity, but the special relativistic effects combined with the huge gravity of the black holes, they skew the shape of this line profile in such a way that in the end, you expect to see that kind of emission line. Okay, so otherwise we would see that. But with the black hole and accretion disk, we expect to see that. Okay, so this is totally theoretical. And even before the observations, some people predicted. And then the technology kept up with the theory, and we actually, so now we're actually capable of detecting those emission lines. And here it is. So this is from one AGN, supermassive black holes. This is another one. And these are the same emission lines coming from the black hole binary systems. And if you compare the theoretical prediction, it captures the essence of the line profile. Right? It's asymmetric, skewed, and the width of the profile, it's also consistent. So this is kind of a smoking gun evidence for the presence of this accreting gas. And another property is, so this is another X-ray spectroscopic observation of many different AGN, different galaxies. And you can see that this hump, right, it's a kind of common feature in all these observations. And we don't really know what makes this hump, what makes this bump. And so here at JMU, we are proposing that, the inner part of the accretion gets very, very hot. And sometimes you can get the shock wave because gas collides and they are supersonic, basically. So you expect to develop a shock wave. And when a shock wave happens, then the gas gets even more compressed, so it gets even hotter, super hot. It's not a thermal emission, but the equivalent temperature is like 1 billion degrees. So you can expect really, really hot plasma here. And when you calculate what kind of radiation comes out of that region, and you can model for this particular AGN, it's called the Arcadian 120. It's about 10 to the 13 astronomical units away from us. So I don't think it means nothing. I don't think it means anything to us. It's far away. We know that it's about 100 million solar masses, and this is actually, I don't know if you can tell, there are actually data points in black, and those are the X-ray observations over 18-hour exposure with this European satellites XMM Newton Observatory. And then we make spectroscopic models and compare with the data. And it looks like it reproduce almost the identical spectroscopic feature. And so from there, what can we learn? Well, we can learn the viewing angle, inclination angle of this system from us. In this case, it's 36 degrees plus minus. And this hot region, the size of the region, that's about 1.3 times the horizon. So it's a really, really small cross to the horizon. And the temperature of that plasma, like I said, this is not really the temperature in the black body, but it's about billion degrees, so it's really hot. And this is called the confidence contours, meaning that at this point is the most likely variable parameter. And at some confidence, you can say that this system is well explained by these variables. And we use this chi-squared statistics, and Peter and Doug were also involved in this study to produce that spectra. Okay, so this is the last question. which black hole is more dangerous for space explorers? Stellar mass black hole, supermassive black holes, both. I have other things to worry about. A, C, oh. Okay, so it's the scatter. Okay, interesting. E looks like A and D are majority. So the answer is supermassive black holes. And that's because if you think about the event, the size of the event horizon, it's huge. It's so huge that you don't even know that you are already crossing the event horizon. By the time you notice, oh, there's something wrong here, then it's already too late. You're inside the horizon. So for future space missions, to explore black holes, we really need to have a careful, detailed map so that you don't accidentally cross the line. Otherwise, there is no turning back. So the take-home message today is that it's not really a scary object if you know enough. And as a science, black hole itself, it cannot really tell us anything. But nonetheless, we can study by this gas called accretion disk. So thank you for your attention. And I can take your questions if you have anything.